First, our brain sends signals to our neuromuscular junction, which sends signals to the sarcoplasmic reticulum, which then releases calcium ions into the thin filament. The calcium ions will then connect to the actin and troponin, which causes ADP and myosin to activate and connect to the actin. Here, the calcium ions are absorbed through the myosin, and it's going on the thin filament, moving, which causes muscle contraction. While this is going on, ATP is created. It relaxes, which cancels out muscle contraction. It pumps calcium ions out muscle cell. Then myosin finally breaks down ATP and breaks it down to ADP and phosphorus to start over process again. The brain sends signals at the neuromuscular junction, travels to the motor neuron and to the axon terminal of a neuromuscular junction. Neurotransmitters are then released into the receptor cells on the sarcomere. Once the signal is received, the action potential travels down throughout the T-tubule. Once it reaches the receptor, it travels into the sarcoplasmic reticulum. Sarcoplasmic reticulum releases calcium, then binds to troponin into myofibril. The balance of ions inside and outside a resting membrane creates an electric potential difference across the membrane. This means that the inside of the sarcolemma has an overall negative charge relative to the outside of the membrane, which has an overall positive charge, causing the membrane to be polarized. Once released from the synaptic terminal, the thing diffuses across the synaptic cleft to the motor end plate, where it binds to acetylcholine receptors, primarily the nicotinic acetylcholine receptors. This binding causes activation of ion channels in the motor end plate, which increases permeability of ions via activation of ion channels. Sodium ions flow into the muscle and potassium ions flow out. Both sodium and potassium ions contribute to the voltage difference, while ions channels control their movement into and out of the cell. As a neurotransmitter binds, these ion channels open and Na plus ions enter the membrane. This reduces the voltage difference between the inside and outside of the cell, which is called depolarization. As acetylcholine binds at the motor end plate, this depolarization is called an end plate potential. It then spreads along the sarcolemma, creating an action potential as voltage-gated sodium channels adjacent to the initial depolarization site open. The actin potential moves across the entire cell membrane, creating a wave of depolarization. Rigor mortis is the process that takes place after death. It is caused because cellular respiration is not happening. Without cellular respiration, the body can't create ATP. Without ATP, the myosin can't disconnect from the troponin chain. This causes the calcium ions not to be pumped out. This keeps the muscle contracted. Rigor mortis begins after 4 hours after death. It starts in the face and smaller muscles. After 12 to 24 hours, it is all over the body. After 48 hours, the body begins to decay. The reason for the decay is the lysosomal intracellular enzymes begin breaking down the muscles. Rigor mortis can be affected by temperature. In cold temperatures, it is slowed down to a halt, like in cold temperatures. Like in warmer temperatures, rigor mortis is faster and decay set and quicker.